Okay, so now we have the door and the pressure plate working. We can move on and set up an item to pick up and place on the pressure plate. So that will require us to move on to scripting the game itself. So what we've been doing so far is more like level scripting. Even while it's being done in separate blueprints, it's still all focused on the level. Where the power of blueprint really comes to shine is in actually setting up the game. You can set up entire games, as I've done with Solus, with just blueprints, going way beyond what Kismet, for example, could do in Unreal Engine 3. So in order for us to set up the game, we need to have our own game type, our own pawn, and our own player controller, basically. These are already set up in the example. So there's a lot of tutorials online also that allow you to set these up. I already have these set up, but basically all of these are blueprints. You can see in the blueprints game folder, we have player, we have the HUD, game state is something more special, ignore that for now. We have the game info and we have the player controller. All of these are just standard blueprints that were created by right-clicking, create blueprint, and then they were parented to the right class. So in this case, the class is really important. If you look at the player, for example, and at the top you press blueprint props for the properties, you can see the parent. And you can see that the parent is character. It's not actor, it's character. And because it's character, it instantly behaves like a character you can control. So all of these have their own parents set up. For example, the HUD here has HUD setup. It's connected to HUD, and that makes it instantly behave as a HUD. Now all of these are then tied together using the game info or the game mode. So in the game mode, which in turn is parented to game mode, in the defaults there you can see the player, the HUD, player controller, and the game state. So this is where we define if this game mode is active, it automatically uses this blueprint player. And then you're pretty much off and set. The level in turn, by the way, then uses that game type, that game info, as default. You can see here, game mode override Solus game info, which is that one. And because the level makes this one loaded, this one in turn loads the right HUD, the right player, and the right everything else. And then you're off. Okay, so those are the basics. Again, I'm not going to go over setting that up. There's a lot of tutorials online that do that. I might actually make one myself also at some point. But I'm going to go on right away to more advanced things. So first of all, we need to have an item that you can pick up and carry. So let's start off by making that item itself. I make a new blueprint. In this case, I'm going to simply use actor again as parent. I'll call it item to pick up. Double click that. I need to have a mesh for an item. So in here, go to the item folder, items, meshes. We'll keep it simple. There's a couple of meshes in here. Some of these meshes are not meant for this video, but for the second blueprint introduction video, where we continue on items. So for now, I'm simply gonna stick to the rock. There's rock 1 here. It's a simple rock. You can see here, I can add it to the level for a moment. We want to be able to pick this up and place a couple of them on the pressure plate to press the pressure plate down. Okay, so I have that mesh selected. I'll go here and I'll add this as a static mesh, same as we've done before. Now we have that. I can add the blueprint to the level already. So here we have the rock. I need to make sure it has physics. It should be falling down. It's an item after all. So let's start there first. Let's set the right physics. You can do that by going to the physics section and you enable simulate physics. And it's also start to wake and has gravity, etc. So this should actually work. Let's just try to play this. And you can see it fell down. So we have a rock here. Next up is, you can see there's a small crosshair in the middle of the screen. That crosshair should be able to detect the item, and when it detects the item should light up. So we need to get an outline similar to Left 4 Dead or other games to show up the moment you the item is underneath your crosshair. And then the second step, once we have that, is to enable us to click on it, and when clicked, the item should disappear from the ground and instead be added to the player and show up on the right bottom side of the screen until we drop the item again. Let's set up the outline first, and to do that we need to be able to detect when the player looks at it. So open up the player blueprint, open up Solus player, and then you will get this. So this is the pre-made player, part of the example project, so this is already all there. That's fine. So we're going to extend this now. We need to know what's in front of the player, and in order for us to know what's in front of the player, what we will do is we'll use the camera, because the player has a camera. In the components here there is a first-person camera. This is the camera actually used. You can see this is the player here. The capsule is the size of the player, so basically the invisible body. You can see this thing here is the hand of the player. This is invisible in game, it's just to be able to see what we're doing, but this is the hand, so the item will have to be attached to the hand. And then this is the camera, so we want to be able to know from this point forward, and if that hits something, we want to do a trace. If that trace hits something, then we know that the player is looking at an item. Okay, so in order to do that we need to trace, and a trace is nothing more but a line. So it will simply start the line somewhere, and then it will move forward, and it will detect what that line hits. So we're basically really just checking what's in front of a certain position. So if you type trace in the right click menu, you have a number of different traces. In this case you want to use a single line trace for objects. That seems to work best in this case. So single line trace for objects. I place it somewhere around here, and then I'm going to connect it to the tick. So there's a tick event here, and what a tick event does is it executes all the time. For every frame this executes, and you can see then after the tick event I have a sequence, so I simply split this up in a lot of different things so I can connect a lot of different things to the ticking, right? So I can see very clearly if I add a print message to one of these outputs here, and I type test or whatever, and I play the game, I don't just get one single print message, it's all the time. You can see it keeps on going. So tick executes continuously all the time. You use tick for anything that has to run continuously, and the check whether an item is in front of you or not, that is something that has to run continuously. So connect it to that. And then it's not going to work as it is. You can try actually, try to compile. Doesn't work because we haven't defined start, end, and objects type as well. So first thing, object types. We need to enter something here. What I can do is I can add make array. And when you do make array, you can add a different collision channel basically to it. So basically what this is you can make the trace ignore everything except this type, because we don't want the trace to respond to the world, for example. It should only be checking for items, not the world. So you can set this to something specific. I'm actually going to set it to vehicle because I don't have an item type in here, but I do have vehicle, and I'm not using vehicle in the game, so I'm simply going to abuse the vehicle type for the item instead. And if you go back to the item here, in the properties of the static mesh component, you can see here it says physics actor, and you can set that to vehicle, and that should do, I believe. So there's that one. Then we still need to know where to begin from and where to end. Between which 2 points should the line exist? You could enter that, but entering that wouldn't really work because the player is moving around, so this location is ever changing depending on where the player is and what the player looks at. So what I need to do I first of all need to know the camera. What is the camera? The camera is on the left, called first person camera, which again, it's the same as the component's name, so that's simply the component as a variable. So I'll get the first person camera. I'm gonna need a bit more space here, so I'm gonna do that. And then I need to know where in the world first person camera is, because I need to have the vector. I need to know where to begin the line from. The line has to begin from the camera, so I need to know where in the world is the camera right now. So I do get world location. Now I know the position of the camera in the world at this very moment. That's where the line begins from. So that goes to start. But then the end one is harder, because I can't just say take 400 units in front of the camera, because I don't know where the front of the camera is. Because this position is just where the camera is, it's not where the camera is looking at. So I need to know what the camera is looking at. And in order to do that, I can get forward vector. And get forward vector gives me the orientation that it looks at. However, the number it outputs there is very small. And you can always test these things, by the way. So if you have cases like this where you don't know what it's doing, or where you want to see the numbers it's using, what you can do is you can add a print. And you can connect actually a vector or a float or anything else directly to the string from the print, and it will convert it. So this thing in between here that converts a vector to a string. And then you could use that, connect that here to that. I'm going to disconnect this for a moment because otherwise it doesn't compile. And then when you play the game, that would allow you to see what forward vector actually outputs. And you can see as I look around, the number changes. So each number represents a different axis and a different direction. As you can see also, that number was quite small. It was between 0 and 1. And 0 and 1 is too small. Because that's in units, and that would only be 1 unit, that's not a lot. So what I will do is I will multiply this. If you begin dragging from get forward vector, and you type the asterisk symbol, or the whatever you call this, or you can also just type multiply if you wish. Then you get vector times vector, so vector multiplied with vector. You could do the float one as well if you want, it's about the same. You get this, so it will now multiply this with this. And let's say we will make this 300, so I'm simply going to type 300 everywhere. And that means it will take a position 300 units in front of the player. So basically it will check in a 300 unit radius in front of the player whether or not it's looking at an item. So if the item would be there, and I'm standing here at the edge of the room, and I would be looking at the item, it would not detect it because the trace only goes 300 units in front of the player. So this is the range of how far it checks whether or not it can see something. And then, because this number still isn't what we need, what I will do is I will take the world location where the camera is, and I will add the other one to it. So I do plus. Again, it's just a plus symbol, and just type the plus symbol and you get it, or you can just type add as well. But then you get a bit more results and it's a bit harder. And then this becomes the endpoint. So now we have that. That should now compile. That compiles fine. And you can see it says here draw debug type. I'm gonna temporarily set that to for duration. This will make the trace actually show up in the game so I can see what it's doing. So if you now play this, you can see as I look around, I'm drawing these lines. This is the trace in action. You can clearly see what ticking does as well. Tick means it continuously outputs and triggers whatever it's connected to. So it keeps on doing this all the time. So I'm really drawing lines. And you can see it correctly begins at the camera and looks forward. See if I walk back, you can clearly see the lines. Actually, it's quite hard to see, but the line keeps following the center of the screen. And I can then use that to detect this. You can see the line starts to turn green. That means it has hit something. So it's red until it's red when it hits nothing. The moment it hits something, it will begin going green. And you can see it doesn't go green when you look at the ground, but the moment you look at the item, then it goes green. So it detects the item correctly, and we have that going. We can furthermore expand on that because we have out hit. Out hit is what it hits. So this gives me all kinds of information about what it's doing. So if I take out hit, which is a dark blue struct hit result output, it's kind of hard to use. What I can do is I can break it instead. If I break the out hit result, then I get a lot more information that's all embedded within this big one here, and it gets a lot easier to use. So for example, I could say hit actor. I want to know what it hits. So I could do connect a print message for a while, print, and then I want to see what it hits in order for us to test what it's doing. Now I can't connect this directly. I'm not sure why Epic doesn't support this right away, but what you can do is you can drag from there and then type string, and you can do toString object, and that works. So this is the same as what we've done with the vector. It simply converts this into a string, allowing us to output it to the screen so we can see what it's doing. Let's try again. You can see right now it's looking at nothing, it's not hitting anything. It also doesn't detect the wall, it keeps on saying none. But if I now look at the item, now it suddenly sees the item as it says item to pick up C2. That's the one we placed. So we got the player to now detect the items on the ground. That's good. So we can then use that to display an outline. Now the outlining system is already set up in the example project, so it's actually very straightforward what we have to do here. All we really need to do is the following. I'm going to do it outside Blueprint first as example. There is a property in everything. So for example, if I take the pillar here, every actor has this property, and it's called render custom depth. So enable the property render custom depth. This, by the way, can be hidden in a section like this. So always make sure you press these arrows pointing down, so you see everything. Render custom depth. And you can see you have to be in lighting mode for this, otherwise it doesn't work. You get a red line around it. So it's this kind of outline we want on the object on the ground. Rendering custom depth will activate the custom depth output in the post-process material. So this is already set up, you don't have to set it up, I'm just going to quickly explain how it actually works. Around the level here is a post-process volume. That post-process volume at the bottom has a section called blendables. Within that section we have a mat Solus post-processing material. This is a material set to post-processing mode, and if you open that one up, you can see connected to emissive we have this whole setup here. This part of the arm, that's what handles the outline. So you can see this is the color of the outline. It's this orange-red color we've seen in the viewport, and that gets added on top and then lerped together. So you can see if the outline is active, it will display red, whereas otherwise it would take A, and A is just a normal scene with like some dirt on top of the lens, a drowning state, and some other things. The outline over here, what it basically does is here it gets the custom depth, and the custom depth is nothing but a black and white image of the screen, and every object in the screen that's set to custom depth true will appear white, and every object that's set to just normal will appear black. So basically you get a black and white image in which every object set to custom depth is white and every other object is black. That's why we can use that as an alpha in a lerp. I have 4 of these, so these are 4 times the same. Each of those 4, it has a UV input, so I'm offsetting the UV slightly, and because I offset the UV slightly 4 times in 4 different directions, if I add them together, what I basically get is an outline. So the first time I do it, I offset the alpha, the custom depth alpha, slightly upwards, then downwards, for example, then left and then right. If I add those 4 back together, then it will appear as if the outline, the alpha, is larger than the original object was, and therefore it results in an outline. That's basically what I'm doing. Again, this is more graphical, it's more material setup. It's nothing to do really with Blueprint. For you right now, in Blueprint, all you really need to think of is that you somehow need to be able to tell the item that it needs to change its property from custom depth false to custom depth true the moment you click on or the moment you look at the object. So somehow we need to be able to have it do this. That means that we need to send some kind of signal to this object. So in the item, I'm going to go back to the item blueprint now. In the graph, I'm going to create an event. So custom event. I'm going to call it being looked at. And then I'm going to take the item mesh. So this is the mesh we have in here. It's the mesh defined in there. And on this one, I'm going to say custom depth. Set render custom depth. So when it's being looked at, it will enable it. And I'll make a second custom event actually for when it's no longer being looked at. This is not a waterproof setup. We're going to have to change this later on, but as a first setup, just for example, this would work. So now if I run this event, it will turn on the outline. If I run this, it will turn off the outline. Then we still need to be able to communicate with the item. So I compiled it, otherwise I can't get to the events I just made. Compiling it makes it register whatever I just did. If I go back to the player then, I need to be able to activate this. That's going to be a little bit hard. So the hit actor, that's the item. But if I do hit actor and I type, I think it was looked at. Yes, being looked at. If I type looked at, I don't get the event. I have no way of getting to that event. I have no way of triggering that. And I don't have a way of triggering that because the engine doesn't know that the hit actor is this specific type. Because for all I know, there might be 150 more blueprints in the entire game, and all of those 150 blueprints maybe have 20 custom events in them, so the engine can't really output all 20, or what is it, 20 times 150, I mean it can't output thousands and thousands of custom events in the list over here. So this doesn't display anything, because the engine isn't aware what specific type of object it is. So our first step is to make sure the engine understands that we're really dealing with this specific type of blueprint here and nothing else. And once the engine understands that, we will then gain access to these two events. Okay, so hit actor is going to be cast to item. So if you type cast to item to pickup, we can make the engine understand that it should be treating this object as this type instead. So that's my first step. And then the output here, that's how it actually behaves. So that's actually how it actually outputs. So this one will now actually give me access to my two events. And then you have your access. So I'm going to connect being looked at. And that should do. So let's try this. Of course, this doesn't disable the outline. It only enables the outline. So there's no outline right now. I look at it. It can be hard to see with all the red lines, but you can see the object now has an outline. So that works. Now let's make sure we can also turn this off. And there is a return value here. This is a bool. It's just true or false, and this simply returns whether this hits something or not. So if it hits something, it's true. If it doesn't hit something, it's false. So I can use that to branch it off in two different directions. I can add a branch. I held B on the keyboard and clicked somewhere. I connect that there. I'm actually going to connect this in between. I'm going to say if true, that means you hit this, and then you should tell it to it's being looked at. And if false, it means you didn't look at the item. And then you should turn it off. Now you can already see that this is going to be very shaky and duct taped together. So again, this is not really the proper way, but I do believe this probably works. Even though the hit result will output nothing actually. So actually that's true. We can probably do that, but again, it's not very, this is quite incorrect because you skipped this one, so I'm not even sure this is gonna work. It works, but again, this is really not correct. can see it, the outline appears, kind of subtle, but it works. It's not correct because he might be executing false before he has ever executed true. And when he executes false before he has ever converted this output to something else, then you're going to get a lot of errors. They're not going to appear in game, but in the log files and behind the scenes, a lot of things are going to go wrong. So this is not actually correct. When you're dealing with casting, always make sure that the step before the function is the actual cast. There has to have been a cast somewhere along the line before it gets triggered. And this can technically be triggered before he has ever gone past by this step. Therefore, it's not correct. Anyhow, this works. It's too shaky. It's not really correct, but it does work. So the case we have here is a bit of an issue. For me personally, the most difficult thing about Blueprint is not really about making it, setting it up. All of the calculations, all of that is actually quite easy once you get into it and once you know what kind of nodes you have available, what kind of functions you have available. All of that's quite easy. The real difficulty in general tends to be how you organize things and how you set it up, because you're basically designing systems. And that's where it goes much further than Kismet and where it gets quite complex, especially if you don't have a programmer background. So I think that's going to be the most difficult thing for most people, understanding the big picture, understanding the implications of how you set up systems. Okay, so the biggest problem we have here is that no matter what we do, we can never make it do this. So as I said, if I would have casted in between as well, it also wouldn't have worked. This doesn't work either, especially not with that line, but this doesn't work either. Because if it doesn't hit something, if it's false, then this is none. If this is none, if this is an empty object because you're looking at nothing, then he can't convert an empty object to an item and then tell that item is being looked at. So we need to be able to work around the fact that the engine loses the fact that it doesn't know anymore what it's looking at, simply because, well, he is looking at nothing. In order to do that, I'm going to temporarily save to a variable the object the player is looking at. Therefore, I have the variable stored. I have it stored somewhere what I was looking at, and then while I have it stored, I can still tell the item to turn off whatever it was doing before I clear the variable that was stored. Okay, that sounds more complicated than it is really, but it does require us to make a new variable on the left. So what I'm going to do here on the left is I'm going to say the actor here, and actually you can do this on the left. You can click new variable, but there's an easier way of making variables. You can also just click and drag from hit actor, and now you get promote to variable. If you click that, it instantly makes a variable of the right type actor here, and it's instantly in the right place as well. So I'm going to call this item in view. So I'm going to store whatever the player is looking at in a variable, so I can call on this to remember what I'm looking at. And also it should be noted here that if you make a variable, you can see I tend to type them like this. I tend to type them with a capital letter for every separate word. And the reason why I do that is because of this. By doing so, it's one word here because you can't have spaces in variable names, but it will show up with a space in here. So it automatically translates capital letters by adding a space in between that and the previous letter. Good, I'm going to set this. So I'm going to set it when it looks at something. So if looking at something, then I'm going to remember what it's looking at. So I add it in between here. And in fact, then I don't need this line anymore. I can also call directly on the variable we just made. So if I do get, this now represents that because we're setting it here. So we're setting that this is now assigned to this variable. This is now stored in here. So this thing simply represents this output. This makes sure you don't have as many lines going everywhere. I can actually I can delete this one. So I store the item and then I instantly tell that item that I just stored in here that is being looked at. When it's no longer looking at something, what I'm going to do is this. I duplicate these two. And then I will clear the item in view. So I do set item in view, but I do it at the end. So when I look at something, I first set it, it's the first step I do, but when I stop looking at an item, it's the last step I do. As a last step, I will clear it. So I just keep sure it's none, it's empty. Therefore, when you stop looking at something, this still translates as empty, but the item is still being told to turn off the outline before we clear it. Okay, that's quite a step for an introduction video. Let's see if this works. So it might be hard to see on the video because it's quite a thin outline. But as you can see, the outline appears and then disappears. So it works. Good, so then the next step is that we need to get this stuff, the item, attached to the player. We need to pick it up from the ground and then attach it to the player when the player left clicks. So let's first of all handle the left clicking part. What I can do here is I can get a left click event. If you right click and you type item grab, or let's just type grab actually, Solus grab item, this is left clicking. In the same way you can do drop item and you get this. This is left click, this is right click. You don't actually want to do, you can actually do this, but you don't want to. You could do left mouse button, type left mouse button, and now you get the player clicking with left mouse button. But this would mean that you hard code the keys into the game, and that wouldn't be very good if you later on want to be able to change your controls. So what I did instead is I made an action and I assigned the key to the action. So later on in the game, if you want to change your controls, you can change the controls, but the blueprint remains the same because the blueprint is bound to the action, not the actual key itself. And those actions are defined in the input ini file, or these days you can also access them through project settings, I believe. And then somewhere here it says input, I believe. And here you see action mappings. It says Solus grab item connected to left mouse button. Because of that, so these actions defined here, they will also appear in Blueprint. And that prevents you from directly mapping keys directly into Blueprint. Good, so we have left click and right click. Let's start with left click, so I'll just move the other one away. Because I now know what I'm looking at, item in view after all, I can then do something with this. I can do all kinds of things with this. It hasn't been cast yet though, so I should probably still cast first. So I'm gonna cast to item. So on clicked, if you're looking at an item, then what I will do is I will move it to the player. And in order for me to do that, I need to know where the hand of the player is. I will actually move it to the hand directly. So I'm going to get the hand animation, which is attached to the first person camera. So the hand follows the camera. So I basically want to teleport the item directly to the hand. And then I actually wanted to go to the socket of the hand, because the hand itself is located there, but I wanted to go here. This is what represents the hand. Within that, there is a bone, a socket, that's defined outside Blueprint, but it's already defined in the asset. So the asset is aware of the fact where this bone is located or this socket is located. So what I can do instead is I can do get socket location. And the socket is called hand. To get the location of the hand, and that's where the item should be moved to. So this thing, or actually you don't even need a cast in this case, let's just keep it simpler. The item in view will have its set world location. Or set actor location rather. Set actor location. Set to this new location. So the moment you click on it, it should be teleported directly to the position of your hand. I'm gonna move this away temporarily. And also, actually, before we test this, one other step is it should also change its rotation, because the object on the ground might be rotated, and we want to make sure that it's always rotated in the right way when you pick it up. So for example, if you pick up a stick, the stick would always point up and not in some random direction. So what I'm also going to do in a similar way is I'm going to get socket rotation. So get socket rotation, same thing here, hand. That then outputs a rotation value, and in similar setup as the previous one, I do rotation, set actor rotation. And it takes over the rotation of the hand. Let's see if that does something. And that does, because now every time I click on it, it will teleport to position of the hand. Again, the hand is invisible in game, but it will basically just teleport every time, as you can see. That works. It doesn't stick to the player, however. So the next step will be to attach it to the hand. But before we can attach it to the hand, we need to take the physics away, because the object is physics driven, and we wouldn't want to attach a physics driven object to the player. That would go wrong with the physics. If you really want to attach a physics driven object to something else, you will need to use a constraint, a physics constraint, but that would be far too complex for a situation like this, and far too unreliable as well. So it would be much safer if we simply take the physics away while the object is attached to the player, and the moment you drop the item, the physics would return to the object. So what I'm going to do here is I'm going to add more events. I have an event for when it's being looked at and for when it's no longer being looked at. I also now need an event for when it's being picked up. So I'll add a new custom event, call it item picked up, and another custom event for when it's dropped, item dropped. And I'm going to say when it's being picked up, item mesh, and I'm going to say physics simulation, set simulate physics is disabled. And because the mesh also has collision and we don't want the collision to interfere with the player, I'm also going to say when picked up, set collision enabled, and I will set it to no collision. And then the drop one is the inverse of that. And actually, in fact, what I'm also going to do is I'm going to say when you pick it up, it sets custom depth to off, just to make sure there is no chance that custom depth still is enabled because you've picked it up, in case it doesn't do it automatically. There we go. And here we say collision enabled, and it's physics again. Actually, to be safe, you need to do this the other way around. You first enable collision, then you enable physics, because the physics relies on the collision, so you don't want to first enable physics before the collision is active already. So this is the correct setup. Over here it is correct, because it's the other way around. And then actually you want to activate these two events. So I compile it, go back to the player. I'll take this one that I already have here, and then I'm going to say, okay, so then we cast, and then we tell the item that is being picked up, like so. We can try this. So this means that we're going to pick up the item will teleport to the hand, and then it should have no longer any physics, so it's probably going to stick to the position where it's at in the sky, and it's going to stay there, as it does. So that step is working. Next step, we need to attach it to the player itself. So I will get item in view. Again, I'm not casting when I don't have to. So for example, here I'm not casting because set actor location and set actor rotation, that works independently of whatever type it is. So this always works on whatever object it is. But this, however, that's unique for just this type of object. So when I'm dealing with unique functions or unique variables, that's when I cast. When it's universal stuff, I do not cast. Good. So then this one, I'm going to attach it to the player. So I'm going to say attach actor to component, not to actor. I want to actually attach it to a component within the player. If you do actor, it will attach to the middle of the player, and that wouldn't be very good. So attach actor to component. The target is the item we're looking at, and the parent is the hand animation. And again, same thing here. Socket name, I'm gonna type hand, right? And I can't apparently type very well, so and then I'm gonna say keep world position, so it remains where it already was in the world when it gets attached. But the thing is, since we've just teleported basically to the position of the hand already, it's gonna attach to the hand exactly where the hand is. So again, you could do keep relative offset, that means, or snap to target. That basically means it will pretty much snap instantly to the hand by itself, but then I wouldn't have any control over the rotation or other things, and I prefer to have a bit more control. So I'm doing this step manually. Okay, so keep world position, and this will attach it. Again, we can quickly try this, see what it gives. So you can see I'm now holding the item, I can walk around. It even moves a little bit because the hand has an idle animation. It's actually animated, so because the rock is assigned to and attached to the hand, it also moves up and down a bit. I can't drop it, however, so we're still missing that step. So over here for drop item, this is basically the opposite of what we've just done. So first of all, we have to detach it. Detach actor from actor. In this case, there is no component or anything else, but that's fine. There we go. And then we need to cast the item. And tell the item that it has been dropped, and that it should therefore enable its collision and physics state again. So let's try this. So I can pick up the item, and when I right click it doesn't drop still, however. When you're confronted with cases where it doesn't seem to work, what you can always do is enable blueprint debugging. So if I bring, the game is running in the background still, I alt-tapped out of it, and I bring a blueprint while the game is running. And at the top you have this section here, called Solus player whatever, the number always changes. If you enable that, you have a real-time view on what it does. You can see it keeps on triggering this, for example, every second, and this as well. And you can see very clearly that the ticking, it continuously runs. In fact, you can even use this to look at what it actually looks at. So I can see hit actor, and I can actually see the item that it looks at. So you can see the value of everything you have in here. Right, so you can use this to see what happens and why it doesn't seem to work. So go step by step. First of all, check if it actually seems to register this one or not. And it does, because I just right click. Now this is off the resolution a bit of the video, but I can move it a bit. But right click, you can see a signal is being sent. So that seems to work. Then the question is, does the item actually receive it? So I can go to the item as well, go to item pickup, right click, and you can see, no, the item doesn't actually get it. Nothing shows up over here. So that would be the problem. I'm guessing because this one is now set to none, and because this is none, it is no longer able to execute that one. So that's our problem. So what we have here is perhaps not entirely reliant, because the moment we pick up the item that's in view, it also goes out of the view, because the act of picking it up also makes sure the item is no longer in the middle of your screen. Therefore, you can never drop it anymore, because this is now none. So to work around that, I'm going to make a second variable called item you hold. And what you can do, actually, it drops a bit of the resolution here, so let me do it again, is you can even directly set this as item to pick up. Because what we've done here with item in view, this is an actor. You can see this is type actor. But that means we have to cast it each time. It would actually be more efficient if we would instantly define it as the right type. This is instantly defined as the right type. Because by doing that, it will give me access to the functions and the variables within without casting. See, now we've actually skipped the casting step directly. So as the next step, you can also do that. Good, so we have that going, but then we still have to define it. So what I'm going to do is I'm going to say this is going to get set every time you pick up something up. Now we want to do this quite early on. So I'm going to actually do it all the way in the beginning here, because we don't want to be doing it at the end, because there is a chance that this already gets unset before this reaches the end. So I don't want to be running that risk. Even though it seems to work, it's still a bit risky. So I'm going to convert item in view, get, that's going to become item you hold the moment you left click. Now here's the next problem. I can't do this. I can't do that because this is actor and this thing is item to pick up. It's two different types. They're both blue, but they're actually two different types. So what I'm going to do first, I'm going to cast this. So I'm going to cast one more time to the item. And this last time that we've cast, now I can connect this to that, because this is now the same type as that. So the moment we look at something, we will remember, we look at something, we click, then the object we were looking at, we clicked on, that becomes the item we hold. Therefore, from now on, I can simply refer to this one rather than that one. Then I need to replace these with a new one instead. I could do that manually, but it's much easier actually if you click and drag, and you can see if you drag on top of it, make sure you don't drag on top of the text. If you drag on top of the text, you get this, which is not correct. But if you drag on top of the empty space on the left of it, there, it converts this one into that one, so it reassigns it. It's much easier to replace things that way. Actually, we no longer need the cast, so I'm going to go directly there. That's that, and then when you drop it, it's actually I didn't connect it over here. And then we also need to make sure that the item we hold is being cleared when it's being dropped, because when you drop the item, you're no longer holding something, so we need to clear this. So I'm going to do set item you hold, but I don't assign anything here. I keep it empty, therefore the item you hold will become none. So now I have that. Let's see if that works. So it works partially. I can pick up the item, and actually now it works. So it might be a small bug somewhere, but I can pick it up and I can drop it. So left click, right click. Again, there does seem to be a small bug somewhere. I can look into that in a moment. But it gets thrown and it falls down. It seems to work so far. So then for the small bug we have, it doesn't seem to send information to the item. That seems to be the big issue. So let's run debug here again. Look at this. Right click does actually seem to work in this case. It turns out actually that the item doesn't always drop because the order is actually, after all, incorrect. So if I change the order around here for drop out item, it does work 100% of the time. That said, however, what we can also do, because we have a problem right now with the fact that there is collision on it, which we might not want. I don't have collision on items in the world, in Solus. They do have collision, of course, for the world, but not for the player. Because the problem is the player walks on top of the rock, which could be something you want to have. So for example, maybe you want to actually be able to build things, be able to build ladders or piles of rocks to climb on. But they can also give issues with the player's collision. So let's say we don't want collision on the rock. To set that up, what we can do is we can change the collision types. So if you go to the components of the item, then here it says collision presets vehicle. This is what we said earlier in order for the player to detect what we're looking at, because this is set to vehicle as well. This vehicle, however, is not the same as the vehicle over here. So I could have actually taken other options as well. It's a bit confusing because there is 2 times vehicle. You can see object type is vehicle as well. And that makes it a little bit confusing. What I can do is I can set it to custom instead. And that shows up, shows the entire list over here. And you can see here it also says vehicle as well. It's actually this list here, the object responses, that matches this list over here. And you can also see there is one called pawn. So if I set the pawn one to ignore, then this is going to collide with all of these types except with the player, pawn being the player. So therefore at this point I can now walk through the item, but it will still have collision and still hit the world. You can still see it still falls down, but I can just walk straight through. And I can also drop it and do with it what I want. So that's a different way of doing it, and given I now have that functionality in here, I might just as well simply remove set collision enabled and just stick to set simulate physics. Same here, and keep it simpler.